Okay, so we are looking at example 4 in class review. Number 1 says let f of x equal 4x cubed minus 9x squared minus 6 on the closed interval, and we want to find the absolute extrema. So if it's a closed interval, we know that absolute extrema occurs either at the endpoints. So I'm going to test both of these endpoints in my original function. And anytime you put something in the original function, that gives you a y value. So I'm literally comparing my y values to see which one is the biggest and which one's the smallest. And absolute extrema only occur at the endpoints or at any critical values in between the endpoints. So I'm going to take the derivative of this function and see if there's any critical values in between those two endpoints. So it's taking the derivative, I get 12x squared minus 18x equals 0. I can pull a 6x out of both of those, leaves me with 2x minus 3. So I've got two things equal to 0. So either 6x equals 0, which means x equals 0, or 2x minus 3 equals 0. So 2x equals 3 and x equals 3 halves, which is 1.5. Now the big thing about these critical values is you only want to test them if they are within the interval given to you. So 0 is not between 1 and 3, so I'm not going to test 0. But I am going to test 1.5 because that is between those two. So I'm testing f of 1, f of 3, and f of 1.5. And I want to see what these y values are going to be. Okay, and the quickest way to evaluate a bunch of numbers into a function, into the same function, is to use your calculator and go to your table. So I'm going to go to my calculator and I'm going to go to y equals, and I'm going to type in my original function here. So I have 4x to the third minus 9x squared minus 6. 4x cubed minus 9x squared minus 6. And then I'm going to make sure my table is set where I can ask it. So I'm going to go to second window. I just went to second window, and underneath independent, I'm going to put it on ask. Okay, so now I can go to second graph, and I can type in my x values, 1, 3, and 1.5. And I'm going to write down these y values. I got negative 11, 21, and negative 12.75. Okay, so this is definitely the largest one. So it says, where does the absolute minimum occur? What is the absolute minimum? That's a y value. Where does the absolute maximum occur? So I just found my maximum. It occurs at 3. What is the absolute maximum? It's 21. So the y values are always your max and min. Here's the smallest one. And so where does the minimum occur? That's at 1.5, and the minimum is negative 12.75. So we're just comparing our y values, and the actual y value is the max or min. X is where it occurs. Okay, number 2. A company is manufacturing a new video game and can sell all it manufactures. The revenue in dollars is given by, and I'm going to rewrite my revenue equation down here because whenever you have a number in the denominator, you can pull that number out front, and it makes it a little bit more user-friendly. It says where the production output in one day is X games, that's the production output. If the production, X, is increasing at 10 games per day, so that's the rate at which X is changing with respect to time. It's increasing, so positive, 10 games per day. When the production, when X, is 250. Find the rate of change of revenue. So I'm looking for the derivative of the revenue with respect to time. So taking the derivative of my revenue equation here, derivative of r is 1, but I just took the derivative of r with respect to time. Derivative of 36x is 36, and I just took the derivative of x with respect to time. 2 times negative 1 over 20 is negative 1 over 10 x to the 1, and I just took the derivative of x with respect to time. So I took the derivative of everything with respect to time. Now I'm going to plug in the numbers I have. So I'm going to have this equals 36 times 10 minus 1/10 times 250 times 10. This I can put into my calculator. So plugging it into my calculator, I get 36 times 10 minus 1/10 times 250 times 10. And I get 110. Okay, so dRdt equals 110. So explaining what that means, we know we were talking about the rate of change of the revenue. So we can say the revenue, and since it's positive, it's increasing by 110, and revenue is in dollars. So $110 per, and I'm looking for my time in this problem, day. So the revenue is increasing by $110 per day. Number 3, find the equation of the tangent line. All right, so we're looking for the equation of a tangent line. That's going to be of the form y equals mx plus b. In order to have an actual equation, we need a value for m and a value for b. Once we have those, we have our equation. We know m is our slope and the derivative is our slope. And so what I'm going to do is I'm going to find the derivative, which is my slope, and I'm going to put it in there. And then once I have my slope, my derivative, and I'm given this x value here, x equals 1, and I'm about to find the y value that goes with it. Once I have those three, I'm going to plug them in to y equals mx plus b, and I'll solve for b, and then I'll be done. But the first thing I need to do is I need to find that y value. So I'm going to plug x equals 1 in here, and I get y cubed plus 1 times y minus y equals 8 times 1 to the 4th. Y minus y cancel. Y cubed equals 8 times 1. And if I take the cube root of both sides, I get y equals 2. And just in case you don't know how to do it, the cube root on your calculator is found, I don't know if it'll be on this one. I go, yep, go into math, and the 4th one down is your cube root. The 5th one, you can put in any root you want. So I'm going to do the cube root of 8, and I get 2. All right, so that was the first step I did. So I know y equals 2. So my next thing I want to do is I want to find this derivative right here, because the derivative is going to be the slope. So looking at my function right here, I'm going to take the derivative of everything with respect to time. So taking the derivative of y cubed, I get 3y squared, and I just took the derivative of y with respect, derivative of everything with respect to x. Plus, there's a little product rule going on, part 1, part 2. So I'm going to use my product rule, 1d2 plus 2d1. So 1, just going to write it down. d2, the derivative of y is 1, but I just took the derivative of y with respect to time. So that's 1d2. Plus 2, just going to write it. d1, derivative of x is 1 dx dx, which is also 1. So I don't have to write times 1 times 1. Minus, I'm right here now. The derivative of y is 1, and I just took the derivative of y with respect to x. Again, you don't have to write 1 times that, but you can. Equals, the derivative of 8x to the 4th is 32x to the 3rd dx dx, which we don't have to write. So that is my implicit differentiation right there. I just took the derivative of everything with respect to x. At this point, I'm now going to plug in the point that I was given. So I'm going to plug in my point, which x is 1, y is 2. So x is 1 was given to me and y is 2, I found that. So I have 3 times 2 squared dy dx plus 1 dy dx, oops, plus y minus 1 dy dx equals 32 times 1 cubed. And I don't know why I put a plus y, because I could have put a plus 2. All right, so I put in my x equals 1 and y equals 2 everywhere. So now I have 3 times 4 dy dx. And looking ahead, right here I have plus 1 dy dx minus 1 dy dx. So those cancel. Plus 2 equals 32 times 1 cubed is just 32. So I have 12 dy dx. I'm going to subtract this 2 over here, equals 30. Divide both sides by 12, and I get dy dx equals 30 over 12, which I can reduce. I could take a 2 out of both of those, and it leaves me with 15 over 6, so I could take more than that. So I could take a 3 out of that, and it leaves me with 5 over 2. And just a reminder, your calculator will also reduce fractions for you, so you don't even have to think about it. So if you want to just, on your calculator, type in 30 divided by 12 and hit enter, then you can go to math, your math button right here, and number 1 is frac. And it'll always put it back into reduced fraction for you. All right, so what we just found right here was our slope, our derivative. So now over here, I have the 3 things I need. I have my slope is 5/2, my x value is 1, and my y value is 2. So I'm going to plug those all in. 2 equals 5/2 times 1 plus b. And I can subtract, so 2 equals 5/2 plus b. I subtract 5/2 from both sides. Then I have 2 minus 5/2, which I can figure that out. 2 minus 5/2, math frac, is negative 1/2. And now I have my equation because I have my slope and I have my b. So I have y equals 5/2 x minus 1/2. Number 4 says find dy dx. Okay, so I'm going to take the derivative of everything with respect to x. This first term is a product, so that's part 1, that's part 2. I'm going to use my product rule, which says 1d2 plus 2d1. So taking the derivative, 1, I just write it. d2, I take the derivative of my 2 term. So the derivative of y cubed is 3y squared, and I just took the derivative of y with respect to x. So that's 1d2. Plus 2, I'm just going to write my 2 term. d1, derivative of 3x is 3 dx dx, which I don't have to write. Plus, derivative of 2x is 2 dx dx, which I don't have to write. Minus derivative of 5y is 5, and I just took the derivative of y with respect to x. Equals, derivative of 4x squared is 8x dx dx, which I don't have to write, plus the derivative of 24 is 0. So here's my derivative, implicit differentiation, derivative of everything with respect to x. What I want to do at this point is I'm solving for dy dx. I've got 2 of them. They're both on the left side of the equal sign, which is great. I'm going to keep them on the left side of the equal sign, and I'm going to move everything else to the other side of the equal sign. So keeping these 2 terms, 3 times 3 is 9xy squared dy dx, and I'm also keeping minus 5 dy dx. But I'm going to subtract this term to the other side, and I'm going to subtract that term to the other side. So on the other side, I currently have 8x, but I'm going to subtract y cubed times 3, I'm just going to write the 3 in front, minus 2. So I moved all of my constants to the right, or all my stuff that didn't have dy dx to the right, and I kept my dy dx terms on the left. Now that everything on the left has a dy dx term, I can factor it out front, and it leaves me with 9xy squared minus 5. Since it's being multiplied to everything in parentheses, I'm going to divide by everything in the parentheses. All right, and so dy dx equals this term right here. The only way you could cancel something is if you could like pull out a common factor in the numerator, which we can't, there's no common factor, and pull out a common factor in the denominator, which we can't. And then, but if we could do both those things and cancel them, that's the only way you could cancel some. All right, number 5. Tanner is riding a bike due south toward his house at a rate of 15 miles per hour. All right, so here is the house, and he's going south toward his house. And this is Tanner. I don't know how to draw a bike, so I'm just going to put a T there. I'll get back to the rate. Meanwhile, Mason is riding his bike away from the same house due west. So Mason's going this way at a rate of 10 miles per hour. Okay, at the moment that Tanner's 4 miles away from the house and Mason is 7 miles away. So if this is my X and this is my Y, then I know Mason is 7 miles away and Tanner is 4 miles away. dy dt is telling us the rate of change of Y. So since Tanner is getting closer and closer to the house, Y is getting smaller. So I know my dy dt is going to be negative, and he's going toward the house at 15 miles per hour. dx dt is the rate at which my X value is changing. And since X is getting bigger as Mason goes further and further away, it's going to be positive, and it is 10 miles per hour. Then the question says, how fast is the distance between Tanner and Mason changing? So I'm going to connect Tanner and Mason, and I'm looking for the rate of change between them. So I don't know what z is either, but that's okay. This is a triangle problem. So for triangle problems, you're always going to use the Pythagorean theorem twice. The first time is to solve for your missing x, y, or z. So we know x is 7, y is 4, but we don't know z. So I'm going to plug these in. 7 squared plus 4 squared equals z squared. That's 49 plus 16 equals z squared. So I have 65 equals z squared. If I take the square root of both sides, I would get the square root of 65 is 8.062. I'll just leave it at that. That's my z value. We use the other Pythagorean theorem to take the derivative of everything with respect to time. So I have 2x, and I just took the derivative of x with respect to time, plus 2y, and I just took the derivative of y with respect to time, equals 2z. And I just took the derivative of z with respect to time. So now I'm going to plug in all this stuff. I'm going to have 2 times 7 times 10 plus 2 times 4 times negative 15 equals 2 times 8.062 times dz dt. That's what I'm solving for. All this stuff on the left of the equal sign, I can plug all of that into my calculator and get a number. And that's what I will do here. So I have 2 times 7 times 10 plus 2 times 4 times negative 15, and I get 20. So 20 equals, and then those two I could multiply. I could actually not even use a rounded number if I wanted to. I could do 2 times, I'm just kidding, I will use a rounded number. And I get 16.124 dz dt. Solving for dz dt, I'm going to divide both sides by 16.124. And so I have 20 divided by 16.124. And I get 1.24. And so then I got to think about what I was doing here. I was finding the rate at which, how fast is the distance between Tanner and Mason changing? And so the distance is, since it's positive, it is increasing by 1.24 miles per hour. Okay, number 6, it says find dy dt. So we're finding dy dt, and we're given all these values to plug in. They give us dx dt, and they give us x, and they give us y. So I'm going to plug all three of those in once I take the derivative of everything with respect to time. So for this first one, it's going to be a little product going on. I have y times e to the 3x. So those are my two parts. My product rule says 1 d2 plus 2 d1. So taking the derivative, don't know how I wrote that. Derivative 1, I just write d2. If it's e, write what you see, times derivative of the exponent. And I just took the derivative of x with respect to time. Okay, so that's 1 d2. Plus 2, I'm going to write it down, d1. The derivative of y is 1, and I just took the derivative of y with respect to time. Plus, I'm right here, the derivative of 2y cubed is 6y squared, and I just took the derivative of y with respect to time, equals, the derivative of 149 is 0. So now I'm going to plug in all these things I have. So I have a value for y, which will go in right here and right there. And then I have this value for dx dt, which will go in right here. And then I have a value for x, which I will put right there and right there. All right. So plugging these in, I have 2 times e to the 3 times 0 times 3 times negative 5 plus e to the 3 times 0 dy dt plus 6 times 2 squared dy dt equals 0. So e to the 3 times 0, that's the same thing as e to the 0. And if you don't know what that is, you can type that in your calculator. That equals 1. So I have 2 times 1 is 2, times 3 is 6, times negative 5 is negative 30, plus 1 dy dt, plus 6 times 4 is 24 dy dt, equals 0. So if I add 1 dy dt plus 24 dy dt, I get 25 dy dt. And then I can add this 30 to the other side. Divide both sides by 25, and I can take a 5 out of both of those, and so I get dy dt equals 6/5. Number 7. We're given f of x on an open interval. So an open interval, that means we're going to have only one critical value, and that means we'll have only a max or a min, not both. So we need the second derivative to show us which. So what I'm going to do is I'm going to take the derivative here. First thing I'm going to do is rewrite it. So this is f of x equals 3x. When there's an x in the denominator, you can pull it up to the numerator. Then taking the derivative of 3x is 3. Negative 1 times 27 is negative 27x to the negative 2. Okay, I'm going to rewrite that without a negative exponent. And I want to look at two things. I want to know, where does this derivative not exist? I do have a denominator, and x equals 0 would cause it to not exist. But 0 is not in my interval. It starts at 0, but it does not equal 0. So that is not a critical value. So then I'll set this whole thing equal to 0. Then there's lots of different ways you can solve this. My preference is I get rid of my denominator as soon as I can. So I'm going to multiply everything by the denominator, which for the middle term makes it cancel. Over here I'll have 3 times x squared minus 27 equals 0 times x squared is just 0. I'm going to add 27 to the other side. I'm going to divide both sides by 3. And when I take the square root of both sides, I would get plus or minus 3. But again, my interval is only positive numbers. And so I only get x equals 3. This is my only critical value. So I don't know if there's a max or min that's going to be there, but that's the only place it's going to be. The way I find out if it's a max or min is I come back up to my first derivative and I find the second derivative. Derivative of 3 is 0. Negative 2 times negative 27 is 54x to the negative 3. And then I'm going to plug my critical value into my second derivative. The only thing I care is if it comes out positive or negative. So I'm going to have 54 times 3 to the negative 3. And I get 2. Now, I'm not going to even write down the number 2 because I don't care about 2. What I care about is it came out positive. And if it's positive, that means it's concave up, which means this is an absolute min. So I know that there is no absolute max. And I know my absolute min occurs at x equals 3. That's where it occurs. To find the actual absolute min, I need the y value. So I need to plug 3 back into my original function up here. And I get 3 times 3 plus 27 over 3, which is 9 plus 9, which is 18. All right. All right. Cooper needs to build a rectangular fence using a river as one of the sides. All right, so I'm going to draw my river. Here's a river. And we need a rectangular fence. The area needs to be 12,000 square feet. So this area is going to be 12,000 square feet. The fencing opposite the river, I'm going to call these sides X and this side Y. The fencing opposite the river is going to be $3.30. So I'm going to multiply that by 330. While the two sides perpendicular to the river cost $2 each. So times 2 times 2. So I've got two equations going on here. I have the area, which is length times width, X times Y. And then I have the cost, which is 2x plus 3.30y plus 2x. So if I combine that, that's 4x plus 3.30y. So these are my two equations. I'm going to go back in and I'm looking for what dimension should of the field in order to minimize the cost. So that tells me what I'm doing. I'm taking the derivative of the cost, setting it equal to 0, and solving it. that means I'm going to use my area equation twice, which means my area equation is going to equal a number. And that's where this 12,000 comes in. It said that I have an area of 12,000. All right. So using the area function twice, the first time I'm going to solve for either x or y, doesn't matter which. I'm going to divide both sides by y. So I get 12,000 divided by y equals x. And then make note somewhere that, hey, I'm going to come back here at the end and use this again. But for right now, I'm plugging this in to my cost function. So my cost is going to be 4 times 12,000 over y plus 3.30 y. Now I can take the derivative now, but I'm going to clean it up a little bit first. So I have 4 times 12,000, which is 48,000. And I can bring this y up to the top and make it to the -1. All right, now taking the derivative. I have -1 times 48,000 is -48,000 y to the -2. Plus the derivative of this next term is 3.30. So I have my derivative. I now want to set it equal to 0 and solve. So I'm going to rewrite it without my negative exponent there. And I get the derivative equals -48,000 over y squared plus 3.30. Setting that equal to 0, you can solve any way you want. I prefer to get rid of my denominator, so I'm going to multiply everything by y squared. And then I'm going to move up here where I have more room. So the first term they cancel, and I'm just left with -48,000 plus 3.30 y squared equals 0 times y squared is 0. Solving for y, I'm going to add 48,000 to the other side. Divide both sides by 3.30. And I'm going to see what that gives me. So I have 48,000 divided by 3.3 is a crazy number going on there. So I have y squared equals 14,545.45455, whatever. I'm going to take the square root of both sides. So taking the square root, I get 120.605. Okay? So I've got one of my dimensions here. I have the y value. And so one of my dimensions is 120.605, and we were talking feet. So that's my y value. I need to find my other one. So that's where I go back to where I put the star over here and plug it in to find what my x value is. 12,000 divided by 120.605. And I'll do 12,000 divided by 120.605. And I get 99.498 equals my x. So my dimensions that will minimize the cost is 120.605 feet by 99.498 feet. And then it says, what is the minimum cost? So I'm going to come back over here to my cost function. Here was my cost function, and I'm going to plug in the x and the y. So if I plug in the x, I have 4 times 99.498 plus 3.30, and if I plug in the y, that was 120.605. This I can put in my calculator. So 4 times 99.498 plus 3.30 times 120.605. I get $795.99. All right. Number 9. It says find dy dx and simplify completely. So I'm going to take derivative of everything with respect to x. Derivative of 2x cubed would be 6x squared dx dx, which I don't have to write. Here we're going to have a little product going on. We have part 1 and part 2. So I'm going to use my product rule, which says 1d2 plus 2d1. So I'm going to have 1, just write it down, d2. The derivative of y is 1, but I just took the derivative of y with respect to x. So that's 1d2 plus 2, just writing it down, d1. Derivative of 3x is 3. Minus the derivative of y cubed is 3y squared, and I just took the derivative of y with respect to x. Equals the derivative of 9 is 0. So there's my calculus step. Now I need to do some algebra in order to solve for dy dx. And I have 2 dy dx terms. They're both on the left side. That means I'm going to take these other terms that are not dy dx. This one is positive, so I'm going to subtract it to the other side. This one is also positive, so I'm going to subtract it to the other side. So on this side, I'm going to have 3x dy dx minus 3y squared dy dx. And over here, I'll have negative 6x squared minus, and I'm going to write the 3 in front, 3y. So now both of these terms have a dy dx in it. That means I can factor that out front. So pulling that out front, it leaves me with 3x minus 3y squared. Since dy dx is being multiplied to everything in the parentheses, I'm going to divide by everything in the parentheses. Oops. And then I need to see if I can pull anything out, cancel anything. And the only way that happens is if you can pull out a common factor on top, which I could. I could pull a 3 out on top. Leaves me with negative 2x squared minus y. And I can pull a 3 out on bottom. Leaves me with x minus y squared. So I can cancel that 3. So I get that dy dx equals negative 2x squared minus y over x minus y squared. Number 10. Mark's truck is leaking oil in the driveway, forming a circular puddle. Okay, so the area of a circle is pi r squared. The area of the puddle is increasing at a rate of, so that's the derivative of the area with respect to time is increasing, so it's positive 0.85 centimeters squared per minute. At what rate is the radius of the circle of oil changing? So I'm looking for the derivative of the radius with respect to time. When the radius is 4.5, when r is 4.5. So I'm going to take the derivative of this equation, derivative of every variable with respect to time. So the derivative of a is 1, and I just took the derivative of a with respect to time. Here I have a number r squared, so I'm going to have 2 times that number, r to the 1, and I just took the derivative of r with respect to time. Plugging in the numbers I know, this is going to be 0.85 equals 2 times pi times 4.5 dr dt. And I'm solving for dr dt. So if I'm solving for dr dt, I'm going to divide by everything that's being multiplied to it. So I'm going to divide by 2 pi times 4.5. That I can put in my calculator. So I'm going to put in 0.85 divided by, since I'm using my old school 83 calculator here, I need to make sure I put parentheses around the denominator. Otherwise, my calculator will do order of operations for me, and I don't want that. I want it to divide by all of that, which I might actually have to write times there. And I get 0.03, so 0.03. And what I was looking for here was the rate of change of the radius. So the radius is, since it's positive, it's increasing by 0.03, and we're talking centimeters per minute. All right, number 11. Find the equation of a tangent line to this at the point 1,4. So equation of a tangent line, we're looking for y equals mx plus b. In order to actually have the equation, we need a value for m and a value for b. First thing we're going to do is find the value for m because the slope is the derivative. So that's where I'm going to start. Taking the derivative of everything with respect to x, because we're using implicit differentiation, this is going to be a little product rule going on. So I'm going to have 1 d2 plus 2 d1. 1, just going to write it down. d2, the derivative of y is 1, and I just took the derivative of y with respect to x. So that's 1 d2. Plus 2 d1, derivative of x squared is 2x dx dx, which I don't write. Minus, the derivative of y is 1, but I just took the derivative of y with respect to x. Plus, oh, this is exciting, I have another product rule. So plus 1, just going to write it down. d2, derivative of y to the fourth is 4y to the third, and I just took the derivative of y with respect to x. That's 1 d2. Plus 2, I'm going to write it down. d1, derivative of 3x is 3. Equals, the derivative of 768 is 0. So there's my calculus step. Now I need to plug in my point. I was given this point right here, x equals 1, y equals 4. I'm going to plug in my point to make this slightly easier. So if I plug in 1 for x, I get 1 squared dy dx plus 4 times 2 times 1 minus dy dx plus 3 times 1 times 4 cubed dy dx plus 4 to the fourth times 3. All right. Simplifying this a little bit more, I have right here, I have 1 dy dx minus 1 dy dx. So those are going to cancel. So I'm going to go straight to my dy dx term that I have remaining. This is the dy dx I have remaining. It's 3 times 4 times 4 cubed, which I'm going to use my calculator. 3 times, I don't have to do times 1, times 4 to the third. 768. So I have 768 dy dx. And then here I have 4 times 2 is 8, times 1 is still 8. And here I have 4 to the fourth times 3. I'm going to use my calculator on that one. So I'm going to have 4 to the fourth times 3. And that is also 768. Equals 0. Combining those two, I get 876. Just kidding. I get 776. Oh man, it's been a day. Let me add those together. 776. So I have 768 dy dx plus 776 equals 0. I'm going to subtract that over. So 768 dy dx equals negative 776. Divide both sides by 768. And I have negative 776 divided by 768. And I'm going to put it back into a fraction. So I have negative 97 over 96. That is my slope. That is my slope. All right. And so what I'm going to do is I'm going to take my slope, which is negative 97 over 96, and the x value they gave me, which is 1, and the y value they gave me, which is 4, and I'm going to put all of them into my equation of a line, y equals mx plus b, and I'm going to solve for my b value. So plugging these in, I'm going to have 4 equals negative 97 over 96 times 1 plus b. So 4 equals negative 97 over 96 plus b. I'm going to add 97 over 96 to this other side. So typing that in, I'm going to have 4. Can't find my cursor. I'm going to have 4 plus 97 divided by 96, and then math frac, and I get 481 over 96 is my b value. So now that I have a slope and a b value, the equation of my line is going to be y equals negative 97 over 96x plus 481 over 96. All right, number 12. Craig has $1,800 to build a rectangular fence using the back of his house as one of the sides. No fencing needed there. The fence will have a dividing fence down the middle. That costs $5. So I'm going to label these as X, and this long one is Y. This is going to cost $5. The other sides each cost $1.50. So $1.50, $1.50, $1.50. What dimensions will maximize the area? So my goal is to take the derivative of the area, set it equal to 0, and solve. That's my goal. First, I'm going to write out my two equations. So my area is length times width. So that's going to be x times y. And then my cost equation, if I add all this up, I have $1.50x plus 5x plus another $1.50x plus $1.50y. So adding those three together, I get 8x plus $1.50y. I'm missing a number, so I go back and see what it is. He has $1,800, so that's my cost. So 1,800 equals 8x plus $1.50y. So my goal is to take derivative of this area equation, set it equal to 0, and solve. That means I'm going to use this equation twice. The first time I'm going to use it is right now. I'm going to solve for either x or y. And I'm going to solve for y. So I'm going to subtract 8x over. And then divide everything by $1.50. And I have 1,800 divided by 1.5 is 1,200. And negative 8 divided by 1.5 is not pretty. Math, frac, negative 16 over 3. So I have 1,200 minus 16 over 3x equals y. So I have a value for y. And I'm going to come back to this in the end and use it at the very end. But for right now, I'm going to plug this in for y in my area equation. When I plug it in, I'm going to get area equals x times 1,200 minus 16 thirds x. I can take the derivative right here, but I don't want to use a product rule. So I'm going to distribute 1,200x minus 16 thirds x squared. So taking the derivative, I get 1,200 minus 2 times 16 thirds, and you can use your calculator, but that's 32 thirds x to the 1. Set that equal to 0. So I have 1,200 equals, I'm going to add this to the other side. Solving for x, I'm dividing both sides by 32 over 3. And this is where I will go back to my calculator real quick. And I have 1,200 divided by, again, I need my parentheses so that it does not do order of operations for me. 1,200 divided by 13 over 3 is 112.5. So far I have found the x value, the shorter side right here, is 112.5 feet. Okay, so dimensions that are going to maximize the area are going to be 112.5 feet by, and then I plug this back in to that equation to see what I get. 1,200 minus 16/3 times 112.5. I can use my calculator again. 1,200 minus 16/3 times 112.5. And I get 600. So the dimensions that will maximize the area are 112.5 feet by 600 feet. If it had asked what is the maximum area, since our area equation is x times y, I would multiply my x term by my y term. And I get 112.5 times 600. That would be 67,500 feet squared for that area. Alrighty.